Welcome back! We've got our final lesson video in this lesson on interval and radius of convergence. I want to go over a very particular way that we can find interval of convergence. If you happen to notice that your power series is geometric, then you can actually save some time and use the geometric series test instead of the ratio test. But I'm going to give you this warning, and I put it at the bottom of the notes here. Be absolutely certain that your power series is geometric if you're going to use this test, because you'll end up not testing endpoints with this process. And if your series is not geometric and you don't test the endpoints, you could lose some mega points on a test. So with that said, this is wicked cool and I want to show you. So if you have a power series in the form of this, where you have x minus c to the n and you have no other values, no other n values at all, it's just x to the n, some form of x to the n, then it is geometric. So let me show you what I mean. If we expand this out, this would be the same as 3 times x minus 2 to the 0 is just 3, plus 3 times x minus 2 to the 1. Then it's going to be 3 times x minus 2 to the 2, plus 3 times x minus 2 to the 3, and so on and so forth. But here's what I want to point out is this power series is geometric. And you might be like, no, it's not. There's x's in there. Remember, you're thinking about those x's like they are constants. You're going to be plugging in values for those x's. So every preceding term is multiplied by the common ratio of x minus 2. Right, if I multiply each term by x minus 2, I get the next term. So in this case, r, and I guess I'll write that down here, r is equal to x minus 2. And what do we know about a geometric series? They converge if and only if the absolute value of r, which in this case is the absolute value of x minus 2, is strictly less than 1. And we know that geometric series diverge if r is even equal to 1. So that means we don't have to test the endpoints, because we know that this will converge within this interval here. So that'd be x minus 2 is less than 1, which is greater than negative 1. We add 2 to both sides, we get 1 is less than x is less than 3. And that is your interval of convergence. What would your radius of convergence be? Well, again, that diameter from 1 to 3 is a distance of 2. So the radius of convergence would be equal to 1. We take that diameter and divide it by 2. So the radius of convergence is 1. The interval converges 1 to 3. You don't need to test the endpoints because it's geometric. So I'm good with using that. I would probably state formally, if I'm taking the BC exam or I have a very formal teacher or professor, the geometric series shows convergence when the common ratio, the absolute value of r, is less than 1. And then you solve. You don't need to test the endpoints since you used the geometric series. Could you have used the ratio test here? Yes, but you would have to test endpoints. So the moral of the story is, when in doubt, use a ratio test. If you know for certain it's geometric, then use the geometric series test. So I'm going to show you how we can manipulate things to make it geometric. Now looking at this thing right here, we've got ourselves something that can expand out nicely. To the 0, that goes to 1. This would go to 1, and that would go to 1. So we get 1 as our first term. Plug in 1, I get minus x plus 1 to the 1 all over 2. Plus, because I'm going to be plugging in 2, x plus 1 squared. And I'm going to write this as 2 squared so that we exhibit the geometric series well here. And then I'm going to go do one more term, then do the nth term. Plug in 3, we're going to get a negative x plus 1 to the 3rd power all over 2 to the 3rd power plus dot dot dot. And then we've got negative 1 to the n ski, or just negative 1 to the n, times x plus 1 to the n all over, and then be 2 to the n. Now, what's going on here? Like, how is this geometric? Well, you can manipulate this to see that actually what's going on here is you've got minus x plus 1 all over 2 all to the n. If you don't see that here in this, see it here. I've multiplied this 1 by minus x plus 1 over 2. And to get to here, I've multiplied again by the opposite of x plus 1. That gives me the x plus 1 squared all over 2 to give me the 2 squared, and so on and so forth. So that means that r is actually equal to minus x plus 1 over 2. It's pretty diabolical math, don't you think? So it is a geometric series. So I would state this is a geometric series, so it will converge when the absolute value of r is strictly less than 1. So the absolute value of r would be the absolute value of x plus 1 over 2 is less than 1. And I guess I'd put the absolute value of r is equal to that. So now we just need to solve this inequality. Now, to do so, the absolute value of a negative, it dissolves the negative. And so I get x plus 1 over 2. Absolute value is less than 1. The radius of convergence, you don't have that x alone yet. Do not calculate it. I only calculate it once I get the x alone. So I get the absolute value of x plus 1 is less than, I can multiply both sides by 2. And that would mean that x plus 1 is less than 2 and more than negative 2. And I'm going to subtract 1 from both sides. Negative 3 is less than x, which is less than 1. So if you look at that diameter, negative 3 to 1, or 1 minus negative 3 is a distance of 4. Divided by 2 gives us the radius. So the radius of convergence, which I'll write ROC, the rock, is equal to 2. Nice. And the interval of convergence is right here. Because it's a geometric series, there is no need to test the endpoints. Because again, a geometric series would diverge at the endpoints because that's where we would equal 1. And geometric series diverge at 1. Ratio tests are inconclusive, so we'd have to test the endpoints. I'm going to end the video where I started. Please only use the geometric series test for finding interval and radius of convergence if you're absolutely positive that you have a geometric series as a power series. If you're unsure, or you're just not confident, or you know it's not a geometric series, use the ratio test. When in doubt, use the ratio test. You'll be safe. It just might take you a little longer. I thought this was cool to show you nonetheless. I will see you in the exercises. You know you're excited for them. Of course you are. See you there. Peace.